This is Algebra, Lesson 6.5, Writing Point-Slope Equations to Fit Data. This table shows the relationship between the number of years a person might be expected to live and the year he or she was born. Life expectancy is a prediction that is very useful in professions like medicine and insurance. So, what we're going to do is create a scatter plot of the birth year and life expectancy data. On the x-axis, we'll place the birth year, and we will go 1940, 1950, 1960, 1970, 1980, 1990, and 2000. Along the y-axis, we'll put the data for life expectancy, and we'll start at 60, and let's go by twos. So that would make this one 70, and 2, 4, 6, 8, 80. So we can plot this data here to get an idea and check if it is pretty linear. That looks like our data right there. Now I can see the first point seems a little low, but the rest of the points follow a pretty linear trend. I'm going to keep with my scheme. I always say to label the first point x1, y1, and the last point x2, y2. After looking at the data, I might suggest using this point for x1 instead, but I'm going to keep with my normal scheme. So I have x1, y1, x2, y2 labeled. Now I want to use those data points to calculate the slope, and after I have the slope, I can write an equation for a line in point-slope form. So slope is y2 minus y1 on the numerator, and x2 minus x1 in the denominator. So that looks like 76.9 minus 62.9. Is 14 divided by 60 is 0.23. If I have my slope, I can write my equation. Y equals the slope, x minus x1 plus y1. Now this equation is going to give me a line through the first point following the slope of the data. So really it's going to look like this, which is off a little bit, but we're going to use that. The next question asks me to rewrite the equation in intercept form. And that's what was practiced in the last lesson. We are going to take this and distribute the 0.23. I need 0.23 times 1940. 446.2. And we'll keep y1 at the back. And now we need to combine like terms. That is minus 446.2 plus 62.9. So here's my equation in intercept form. Now, remember what this means, which doesn't really fit into the context of our situation, but in the year 0, people had a life expectancy of negative 383 years. Use the point-slope equation to predict the life expectancy of a person who will be born in 2022. Now you can really do this with either equation. You can do this with the original equation, and you can do it with the intercept equation. Either way, we would substitute the value 2022 in for the x variable. We should get the same answer no matter which equation we choose, which is a really nice way to check your answer. So if I do 0.23 times the quantity of 2022 minus 1940 plus 62.9, I get that the average person born in the year 2022 will live to be about 82 years old. I get 81.76. Use the intercept equation to predict the life expectancy of a person who will be born in 2049. So again, we can use either equation. This directions tells us to use the intercept one. We will set the equation equal to 2049 by subbing that in for our y value. And then we can solve that by reversing our order of operations. The first step would be to add 383.3 to both sides of the equation. Then we can divide both sides of the equation by 0.23. Okay, we're going to redo this one. Okay, and our last question says, use the intercept equation to predict the life expectancy of a person who will be born in 2049. So we are going to use the intercept equation this time instead of the point equation. But either way, we're still going to substitute that value in for x. And I get 87.97. Basically 88 years old. That is it for the examples. Good luck on the exercises, and let me know if you have any questions.